Hi boys and girls, this is lesson 13.6 where you're going to apply measures of center and variability, and your objective is I can recognize what the measures of center and variability indicate. So first of all, I need to clarify for you, when we talk of measures of center, we're talking, mean, median, and mode, the three M's there, okay? When we're talking measures of variance or variability, that's how far apart they are. What's the spread from high to low? You're talking the mean absolute deviation, which we're actually not going to use today, but that is part of the variance, and range and interquartile range. These two are the ones we're going to use today, okay? So measures of center and measures of variance. When we talk about measures of center, we use words like typically, on average, and usually. Okay? When we're talking measures of variance, we say vary or spread out. So you will use those words today, okay? So let's look at our first example. Julia is collecting data on her favorite sports teams for her report. Now the table, which is on the side here, the table shows the median, which is a measure of center, and the interquartile range, which is a measure of variability, to the heights of the players on her favorite baseball and basketball teams. How do the heights of the two teams compare? So, in this example, the book has given us some sentence frames to fill in. So I'm going to just slowly read through them, and when I get to a blank, I'm going to use the table to find the answer. So the median of the blank player's heights, that's going to be baseball or basketball, is blank inches greater. So which team has a greater height in the median? Looks like the basketball team. So I would write the basketball team, the median of the basketball. Oh, I can't read that small. Player's height is how many inches greater? Looks like 70 and 78. That would be 8 inches greater. Then the median of what's the other players? Baseball players' heights. And that's how they want us to describe it. This one is taller or this one is shorter. Okay? The interquartile range of the baseball team is blank the interquartile range of the basketball team. Is it greater than or less than? Is the baseball team greater or less? Looking here, looks like the baseball team has is greater. And so this is how I would personally do this. I just would slowly read through the problem and decide what it's asking. The interquartile range of the basketball team. So the heights of the baseball players vary more than the heights of the basketball team. There's more of a variance because that interquartile range is a higher number. So the players on the baseball or basketball team, which one, are typically taller. Which ones are typically taller? The basketball team. So usually the basketball players are taller than the players on the baseball team. And the heights of the baseball team vary or are more different than those of the basketball team. Okay, and so that's what they want you to do today, is to be able to really just explain in words what those numbers mean. Which one's greater, which ones are more often, which ones vary more, which ones are more spread out, whatever the case may be. All right, so here's our next example. And this time they're not going to give us the mean and median. We have to do that on our own. Kamira and Joey sold t-shirts during lunch to raise money for a charity. So they're selling some t-shirts. Here's Kamira, here's Joey. The table shows the numbers of t-shirts each student sold for 2 weeks. So here's on first day, Kamira sold 5, second day 1, so on and so forth. Find the mean and the range of each data set and use these measures to compare the data. So first I'm going to find Kamira's mean, and I'm going to use a calculator on that. So I'm going to add up all of these numbers and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divided by 10. And then I'm going to add up, and I'm going to do this with the calculator. So you guys can pause and pull out your calculators too. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, Joey also has 10. So I'm going to divide those by 10. So I'm going to add up Kamira's real quick. Actually, I'm going to do this in my head. This isn't that bad. 5, 10, 5, 10, 15, 19, 20, 26, 27, 28, 29, 30. Looks like Kamira is at 30 divided by 10. On average, she sold 3 shirts per day. Joey, let's see, he's got 0 plus 1, 1, 2, 3, 13 is 16, 17, 18, 19, 20, 21, 22, 26, 30. I got the same. Did I do that right? Let me double check my work. Hold on. Okay, so I double checked my work, and they are correct that they on average sold 3 shirts per day. And so that was correct. Now we need to find the range. So for Kamira, the most she sold in a day was 5, and the least she sold was 1, giving her a range of 4. Now Joey, he had a really good day where he sold 13, but he had a couple of days where he didn't sell any. He sold 0, giving him a range of 13. So as you're looking at this, you can see that Kamira, she was most of hers was pretty close. She didn't have a very big spread. But Joey, he had some really high days and some really low days. It was very different. So let's go ahead and read through this. The mean of Joey's sales is equal to the mean of Kamira's sales. And the range of Joey's sales it was 13 to 4, is greater than the range of Kamira's sales. So the typical numbers of shirts Joey sold each day was the same as, because it was equal, was the same as the typical number of shirts Kamira sold. However, since the range of Joey's data was greater, remember we had a bigger number than Kamira's, the number of shirts Joey sold varied more from day to day than the number of shirts Kamira sold. And so this is something that I would have you guys explain to me in words, not necessarily write all of that out, because that's kind of excessive. We just have one more. This is a try it problem. Mark collected data on puppy weights at 2 animal shelters. You need to find the median and the range of each of these data sets. Okay? And then use these measures to compare the data. So then explain it in your own words. You only need to write a sentence or 2. Go ahead and solve this problem. All right, so I just wanted to finish up this problem with you. It looks like the median, most of the puppies at the first shelter weighed less than most of the puppies at the second shelter. And in the range, for the most part, there was a good variance. It was pretty close to the same. That's how I would explain this in my own words. Yours can vary, and please show it to me when you check off your work. All right, that's all of the lesson for today. I hope you have a great day of learning.